Nice. So let's talk about variables. Variables that we know and love from math, and then the ability to ask questions in a program and do something depending on the answer to that question is also an important thing that we would like to do in computer science. So let's make sure we know how to do that too. So when we make a variable, we can make something like, I want you to think of it as like a little box. I'm going to make a variable called x. That's a box where I can put something inside. I can put 42 there and get it out again. That's how variables work in computer science, more or less. So let us begin. Get running into those. So all a variable is, as far as computer science is concerned, it's very similar to math. It's just a place where you have something you can save for later. A variable is a place to store information to be used later. Makes your life easier. It's just a box, though. A var is just a box. Alright, so x. We can make a variable called x and have it hold 1,234. So I can just say x instead of saying that long number again. It saved it. And I can do math with x. I can use it, ... Eventually in the program, I can say x plus 1, and like build up bigger computations from the variable. That's useful. Today, especially, we're going to be getting values in a special Scratch-specific variable called input. That's going to take whatever the user gives us. And so if the user types 42, we can get it in a variable called input and do cool stuff with it. Like, I don't know, multiply it by 2. Something like that. So that's where we're going. We want to store stuff for later. And so my first silly example that I can think of how to introduce variables to you would be, let's make, instead of a hello world program, let's make a program where the Scratch Cat asks us what our name is, and then it'll respond to us. It'll say, hello, your name. Hello, Lawton. Something like that. And by input, I think I meant to mean answer. It's going to be called answer. That's okay. It's just a variable at the end of the day. So we're going to make a program, and we're going to get some text from the user. They're going to give us some text data. In computer science, for some weird reason, instead of saying text data, we say the word string. It's like a string of characters, a string of beads with letters on a friendship bracelet like you take to your Taylor Swift concert, all right? So we're going to get an answer back from the user, and like they're going to give us their name, and maybe I'll type mine, and I got some text data. That's a string, all right? That is a string. It's just a bunch of characters. There is a difference then between the string 1, 2, 3 and the number 1, 2, 3. So we'll get into that in a second. But there's an issue there. So let's see. How do I want to do this? Let's go to Scratch first of all. Scratch.mit.edu. Have we all done attendance by now? Can I stop this? I'll give you another minute if you forgot about it. Well, let's do start creating. And does anybody see a block that could maybe ask the user for something? It's one of these. Is it in events? No, we need the green flag anyway, so I'll bring that in. That'll start our programs. I believe it's down here in sensing. There it is. It's ask. Ask what's your name and wait. Okay. So that's the idea. And if I run this, what's your name? I'll type Lawton. Hit enter. Nothing has happened, but the Scratch Cat got our answer, and it put it in this circular thing that is a variable. Right? If I click on it, I can see its value. It stores Lawton now, because that's what's being placed after. That's where it's being placed when I type my name after I run the ask block. If I rerun this name, asking question, and I say my name is, I don't know, ABC, it's going to get that. And it's going to place it into this answer variable, and it's going to hold that answer, right? So that's being held as text data. That's a string. What? You click it. You click it to see its value. So this leads us to a very interesting idea. So if I were to have typed, or if I were to have put a number in a variable, what are things I can do with numbers? There's operations down here. Operators, like I can add numbers together, right? I can't really do that with text. There's the type of something, like a number versus a string, dictates what you can do with that something. So like numbers can be added together, they can be multiplied, but strings, you can show them back to the user, you can print them out, You can make smaller strings into bigger strings. To Scratch, that's called join. You can join strings together. But the type of something tells you what you can do to it. So like I can't add 42 to this answer variable because the answer variable is holding a string. That makes no sense. Okay, so that's the goal. And so let's build up this program so that it will tell us, hello, our name, exclamation point. So like in the answer variable, we get whatever our name is. And then we want to print out back to the user, say for 2 seconds, right? Hello, comma, space, your name. Looks, say for 2 seconds. And instead of saying hello for 2 seconds, we want to say something. Hello, your name for 2 seconds. So you see how this is circular? You can put it in there. So it'll say, right now, if I just give it my name, it'll speak answer back to me for 2 seconds. But I want to build up a bigger string involving answer. All right? So that's down here in operators. There are string operations. A very useful one is join. So it just joins 2 strings together. Join apple, space, and banana into apple, banana. There is secretly a space here, though. Look, if I get rid of it, it's just apple, banana without a space. So it is up to you. So if I want to say hello first, I got to say hello, comma, and it's missing a space right now if I click on it. So it's got to be hello, comma, space, my name. All right? And so that's almost all of it. If I want the final answer, I don't want an exclamation point at the end of that. That's the string that I want to build up. So that involves joining this big string that's being computed with an exclamation point too. So let's do that. Let's bring out another join block. And that gets a little confusing. We got 2 joins next to each other. We have brought them about, and exclamation point at the end of that. So it's like, join these 2 tinier strings into a bigger string called hello space Lawton, and then join whatever that is with an exclamation point. Isn't that fun? So that we can put there, and now it's large. Say all that for 2 seconds. Enter your name, Lawton. It says hello, comma, space, Lawton. It's whatever you typed. If your name was ABC, it will say that. All right, so that is a more interactive Hello World program, I guess. Are there any questions about that? Sorry, it's so large. I can't show it to you all at once and keep it readable. Any questions about it? Yeah. So that's right next to the ask block. Ask block fills in this answer variable with whatever you typed. You just drag it out. We do have options with this join block. Here, let me take it out for a second. Let me duplicate it. Right-click, duplicate. There are 2 ways to make this string, actually. I could have put hello space here, comma space here, and then I could have joined the answer with an exclamation point at the end. I just got to have these 3 things in a row somewhere. See, this will also say the right answer, but where do you put the smaller join is up to you. It's just got to eventually bring together hello and answer and then an exclamation point, or hello, bring that together with answer exclamation point. That's just going to put an exclamation point at the end of answer. These are both going to compute the same thing. I'll add a comment. This computes an equivalent string. Same thing, same answer in the end. Up to you. Do you want to put hello next to answer first and then put an exclamation point at the end of that? Or do you want to put answer next to an exclamation point first and then put hello at the front of that? Up to you. But you've got options, and that is our first program. So let me save that so that you have it later. And if we're happy, let's do more complicated things. All right, here's my next trick. Let's make a program that gets the absolute value of a number. All right, let's have it compute the absolute value of a number. So if we're going to ask the user for a number first, and so into the answer variable it will go, and maybe we typed -42, and our job is to output the absolute value of that number, which should be +42, yeah? And just for fun, we'll have the program start a different way this time. All right, so let's see, do I want to mess with that? Not quite. Okay. So I'll make a new program, file new, delete everything. So instead of having this program start when the green flag gets clicked, why not have it start when we click the Scratch Cat, when this sprite is clicked, because it's the Scratch Cat's program. You can name him Scratch Cat. All over again. So now if I click him, he's going to run all the stuff below this event. So, all right, what are our steps? Ask the user for a number. Let's do that. That is in sensing is where the ask block is. And the answer variable gives us that answer. So instead of what's your name, I guess we want to be like enter a number, colon, something like that. I did. It's up to you. Whatever you'd like. So notice I'm clicking the green flag and the program's not starting. No, that's not how I start it anymore. This one, it's if I click the Scratch Cat, it's like enter a number. I guess the prompt is not next to the little box, so maybe I don't want to put a colon. Maybe I want to put a dot. And again, I got to click him to do this. So -42. Hit enter. And now it's got it in the answer variable. And our job is to output the absolute value of that number. All right, so let's compute that. Is there an operator for that? Yes, there is. Absolute value of answer. That will compute. It knows that answer hopefully was a number, not a string. It computes +42. See that? So that's one of many possible operations. There's a bunch to choose from. Square root, sine, cosine. You can do some really cool stuff, but we'll just stick to absolute value for this one. And then we'll just have the Scratch Cat say the answer. Why not? Say abs of answer for 2 seconds. And again, can't click the green flag to start. You gotta click the Scratch Cat. So -42, +42 is the output. If I type +42, the absolute value of a positive number is still positive, so the output's 42 again. All right, so that's using number stuff on the answer that you get back from a user, right? Because it has a number type, not a string type anymore. That's not too bad, yeah, I hope. Save that, yeah. Mm-hmm. So do you have it just out in the open? You just click on it, you see it? You got to put it somewhere. Put it in a block that actually can run, like I did. Are you able to get the say block out there? Is there something wrong with that? Yeah, so that's in operators. That's down here at the bottom, abs. So it'll compute 42, but we want to say that result as part of the program. Does that make enough sense? Okay, yeah, question in the back. Mm-hmm. What do you mean it disappears? Ah, do you have it outside and you're clicking on it? It doesn't show a result when you click it. It's still got to be outside. Yeah, so this one's not going to run when you click the flag. It's when you click the sprite. That's how we did it. So yeah, so do you have exactly this and it's not doing the right thing? Is that your question? -42 to +42. So yeah, in the back, is this what you have and it's just not working? Yeah. Oh, okay, so that's a weird problem. So yeah, it's not going to get the answer variable does not have a value until you run the ask block. the ask block's job to place your answer in the answer variable. Good. All right, I'm glad we could clear that up. All right. Let me do something completely different if we're ready. So that's number stuff. Now let's do something even fancier. Let's make our own variables. This was the answer variable given to us by Scratch. It exists always. It's here. It's kind of linked to the ask block. But we can make as many variables as we want. We can really make that x variable that I was drawn before. So let's do that. Let's make an x variable that instead of clicking the green flag or clicking the sprite, let's have it increase when we press the space key. Why not? That'll be fun. That'll be a new event. All right. So let's make this kind of program. And so I can either go to File New or just drag everything away if I want a blank slate. So how about when the space key gets pressed, we do something with an x variable that we make ourselves. So if you see on the left side, there's below operators, there's a variables section. And by default, you get a my variable, which you can right click and rename, or you can just click make a variable, give it a name, call it x. And then you don't need my variable anymore. Delete it. Whatever you want to do. You could have also renamed that one to x. But now I have an x variable that I can use anywhere. I can give it values with the set block. I can manipulate its values with the change block, show it, hide it. This checkbox shows it always if you just want to check it and always see it. That's kind of useful maybe. But here's an x variable. It starts out its life as 0. That's like the first default value. But this set block can set it to anything else, like set it to 42. If I click that to run it, that is now placed in the x variable, the number 42. So now if I click it, that's what's living inside. If I run the block again, like make it be 45, run it. Now x is set to 45. So you can use the set block to set your variable. You can also change it. Change x by 1, click that, that means increase it by 1. So now x is 46, click it again, x is 47, click it again, x is 48. You see how this might be useful in a larger program. So yeah, let's start our program where x is at, I don't know, let's just keep x how it is. And then every time we press the space key, how about we change x by 1? And then you can see it change up here. We don't even have to print it out or say it. If you just keep it checked, it'll be shown. So now this is the only real code that's going to run, right? That's the event when the space key is pressed. So if I press the space key, boop, 49, boop, 50, boop, 51. And if you hold it in, it will increase very rapidly. Beautiful. That's a simple program. But let's do something silly. Let's do what I have screenshotted here because I want to show you some interesting facts. All right, so let's maybe I can uncheck this just so that I can copy everything again. So let's set x initially when the space key is pressed to 44 and show it. And then let's increment it, change it by 1. That's what that means, increment it. And then let's show it again. What do you think is going to happen when that variable gets shown? It'll go in the upper left again. Should I see 44? Should I see 45? Like all these 4 blocks are going to run. What's going to happen? So I had it at 44. And this will make it 45, right? Change it to 45. What am I going to see when I press space? Boop. I only see 45. I said this once upon a time, but any block that doesn't have the 4 blank seconds in it happens instantaneously. And so x really is 44 for a split second, but it's really a split second. It's like a nanosecond or a couple of those. So even though it's showing 44 to you, the screen cannot refresh fast enough to show you that 44. Okay? So that's the moral of this story. Our computers are very fast. If you want to see something, like you want to see the value in between, you want to see the 44 before the 45 happens, you have to tell the program to slow down. Make it wait for you. Okay? So that's, was that in control, I think? Yeah, wait a second. So in between showing and changing, like, show me that 44 for a second. There it is, 44. It gets to stay there for a second now before it gets changed to 45. Does that make sense? So all of these blocks that don't have waiting or for 2 seconds in them happen immediately. Blink of an eye. Any questions about that? That's another kind of event too, when space key is pressed. Do this. And that's useful for making games. Yeah. Weird. Are you changing it by 44? Let's see. Yeah, watch out for the difference between set X to 44 that makes it hold 44 and then change, takes whatever's in it and like adds 1 to it. It doesn't set it to 1, it sets it to 1 more. You can also change by -1 to make it go down. So yeah, good questions. Hopefully it's making a little bit more sense. But that's variables in a nutshell. You can make your own. I have a fun idea for us now, though, hopefully involving variables. I want to tell you something. All of the programs that we have written so far are just a bunch of blocks on top of each other. They're all straight lines. It's like run this block. You got some event, right? You got some event that starts off your program. And then you just put a bunch of blocks below it. Like do that one, then this one, then this one. They all fit together nicely. But that's what our programs look like right now. Do thing A, then thing B, then thing C, then thing D, in that order. And so if we simplify that into like a little flow chart, it's like do A, then B, then C, then D. That's what our programs look like. That's all we know how to do right now. And that's kind of boring. You can do much fancier things, and here are the fancier things that you can do. Let's see. I will use rainbow to make it clear how cool these things could be. So one thing we might want to do is branch. So it's like do thing A, and then depending on some question, do either thing B or thing C, not both, just one of those. And then maybe come back and do thing D at the very end. So that's something that would be nice to be able to do one thing or another thing. And then the other final option that is not part of straight line code or branching is looping. Wouldn't it be nice if I wanted to do thing A and then thing B and then come back and do thing A again and repeat this process over and over and over again, so I don't have to like put the same blocks on top of each other to do the same thing multiple times. I could have it come back to those same blocks to rerun them. So that's branching and looping. That would be fun, right? That makes for more complicated, interesting programs. So surprisingly in Scratch, it's easier for me to show you loops. So let's do that. Loops rerun code. And so here's a silly example. We're going to ask the Scratch Cat, we're going to have the Scratch Cat ask us, how fast should he spin? And he's just going to spin himself that many times. So this is an example of loops. Loops rerun code. And so, I don't know, when the up arrow gets pressed, let me write all this out on an actual Scratch page. File new. So another event, instead of space key, how about when the up arrow gets pressed, that'll start this program. The Scratch Cat will ask us, and notice he has a direction. That's how he's going to spin. He's going to spin and change his direction. By default, it's set to 90. So he's going to ask us, how fast should I spin? We're going to give him like some units. How fast should I spin? And then, once we get that answer, like, here, let's run it right now. I'm going to press the up arrow. How fast should I spin? If I type, I don't know, 10. That puts the number 10 in the answer variable. And we can use that number to have the Scratch Cat turn himself. So in the motion blocks, there's like turn clockwise 15 degrees, turn counterclockwise 15 degrees. instead of turning 15 degrees exactly, let's turn answer degrees. And so if it's a smaller number, he'll turn less. If it's a bigger number, he'll turn more. This is a degree value. So if I click this, he's moving 10 degrees at a time every time I click this. That's fun. If I rerun this program to ask by pressing the up arrow and I type 20 instead of 10, now answer holds 20. And if we turn 20 degrees at a time, he turns a bit faster. Yeah. So that's kind of cool. And I would like to repeat this turning to get animation. All right. Animation takes like a split second. It shows you frames at a time if you know how like movies are made. But all that we care about is let's rerun this block. Let's rerun this block 10 times with a loop. All right. So that's over here in control. It's called the repeat block. It's very simple. And notice that it can hold blocks inside of it. Isn't that fun? So this will repeat 10 times, however many you want to give here, but 10 is good for us. It will repeat 10 times running this block. So it's as if it's getting clicked 10 times, or as if it were copied and pasted 10 times. Makes your program shorter this way. All right. So this is the number of times to repeat the inner code, this number here, 10. Change it to whatever you want. Number of times to repeat the inner code. And then everything that you put in here is the stuff that gets run that many times. So this will get run 10 times because we're saying repeat 10. Gets run 10 times. All right. So if I press the up arrow, how fast should I spin? I don't know, 10 degrees at a time. Whee! There he goes. It's kind of leisurely spinning. If I press up arrow again and say spin 25 degrees at a time, put 25 into answer, then I spin super fast. Up arrow to start the program again. 15 is in the middle, I guess. 20. And so this block is getting run a bunch of times fast. This motion block is nice because it doesn't happen like super instantaneously. It happens and then it redraws the screen so you can actually see the spinning happening. But for most, it's really happening quickly though. 10 times fast. Whee! 25. And you could change this 10. You could make this 10 be a value that a variable holds too. Be like, whatever is in X, make it that many times this gets repeated. You can get fancy with it because it's circular. You could have put a variable there. Put some complex computation there. But that's a loop. That's a loop that's getting repeated a bunch of times. Any questions about that? It's pretty obvious that it's going to do some looping, like repeat, and it's like, all right, put everything you want repeated here. It's pretty nice. All right, let me save that so that you have it. We're good with that. That's loops. Now I want to teach you branches, and they're slightly more complicated because the way to get it to do either B or C is to ask a question. And I have to teach you how to ask those questions first. All right? They're called conditions. Conditions in computer science. So, all right. Our goal is to have programs that branch, to do one thing or another depending on the value of a variable, input from the user, stuff like that. So maybe this could be our program that we're interested in. So like if the answer that the user typed was the secret value of 42, if it's equal to 42, then was it equal to 42? Yes or no? If it was, then do thing A. If it wasn't, then do thing B. That's the idea. And then maybe once those are both done, come back and do thing C. Do a bunch of straight line code after that. So this question here, if answer is equal to 42, yes or no, that's called a condition. That's going to drive whether or not we do the left side or the right side. All right? And so let's get technical. We have to talk about what it means to be a condition. What is yes or no inside of a computer? It's called a Boolean. That's the answer that you get back when you ask a question in Scratch or any programming language. You get a Boolean value, which is named after George Boole, if you remember him from the first day of class. Booleans, or bools for short, are values that are true or false. That's the only value that a Boolean can take on. Either true is its answer or false is its answer. All right? So in computer science, yes means true. Yes is equivalent to true. And no is equivalent to false. Right? So You hear me say true and false, it means yes or no, right? That's the fancy computer science terminology. And so we want to ask questions like, is the answer less than 0? And we want to do something if that's true. We want to do a different thing maybe if it's false. Right? So that's the idea. That's what Booleans are all about. And you can get back a Boolean, if I make a new program. You can get back a Boolean with an operator. So like these operations, the pointy ones, the only kind that we haven't seen yet, that gives you back a Boolean result. So like, is 25 less than 50? Click it. True, yes. Yes, it is. Is 55 less than 50? False. No. That's a no answer. You see that? So these pointy blocks give back Boolean values that you can use to control programs executing one way versus another way. Right? Pointy blocks to the rescue. So here is an example that I'm going to have you try in a second, but I'm going to give you the scaffolding of it all before I let you try it. Let's make a program that calculates the absolute value of a number without using the abs block. Ooh, we're going to roll our own absolute value. And here is the idea. So we're going to get an answer from the user. It could be a positive number. It could be a negative number. Maybe it's a negative number this time. But here's what the program should look like if we're making our own abs block. First, we always have to get the input, right? Always got to get the input from the user. Then we need to ask, right? Because we either need to output whatever's in answer, if it's already positive, or we need to negate it and output that if it's negative. So that with the question that we need to ask, the condition we need to have is the input, is the answer variable, is the input less than 0? Question mark. That's what we need to figure out how to ask. And that'll end up being a pointy block, so maybe we'll draw it pointy here. And if it's true that the input is less than 0, so like it really was negative 42 or something, and that in that case, we don't want to output answer immediately. We want to change it. We want to multiply it maybe by -1, because that'll make it positive if it was negative, right? And then we're able to print it out, display it to the screen. Display whatever's an answer after multiplying it by -1. Display. So do you see how if it was negative 42, this process is going to give you positive 42 printed out? That's useful. If the answer was false, if the input was not negative, we do not want to multiply it by -1 and make it negative. So immediately you're ready to display the number. If it was positive 42, just print out positive 42. So do you see how we do need two separate tracks here, because we don't want to like make positive 42 negative by always going this way. We have to do one thing or another depending on the value. All right? So this is what we're going to be translating into Scratch. All right? And the way you do it, the simplest condition and do one thing or another block is called the if-then-else block. In the same place as the loops, is still orange. But here's what you do. Here's what it looks like. You've got room for a condition for a pointy thing. That's where that goes. Your condition's going to go here. Condition goes here. And it's got to be pointy because it's got to become true or false. Must become true or false. And you're kind of forced to have it be like that. True or false. Scratch is forcing that to happen by making it only accept pointy blocks there. And then we have two slots to put code. Interesting. We have slot 1, let's say, and slot 2. The first one will get executed only if the condition is true. That's how it works. Executed if that condition, I'll call it cond for short, is true. And then this one is executed if the condition is false. So only one or the other is ever going to happen. All right. And there's some terminology here. This branch, the side of the branch that happens if the condition is true, we call that the true branch, kind of logically, right? True branch. And then this one is called the false branch. If the condition is false, we're going to run this code, and that's called the false branch. That's getting run. Hopefully that makes enough sense. And so in flowchart form, this is kind of what's going on. You put your little condition, cond, and if it's true, it goes in it and it does all the code that you put in the first slot, in slot 1, does all the number 1 stuff. And then if it's false, it goes and it does all the number 2 stuff. And then after it's chosen one side to go down, you can put more straight line code down here at the end of the block, and it will just always happen. All right? Are there any questions about how this if then else block will work?
How do you know that the first block, or how do you know number one is the first block, and how do you know that number one is the true block, and how is number two the false block?
It just is. That's what it's saying to us right here. It's like if blank is true, then do this, else do this. That's just what it means. It's always the first thing is if it's true, the second thing is if it's false. Else kind of implies if it's otherwise, right? If it's false, this other thing. So it is always that order. So if it's true, we do this one. If it's false, we do this one. Yeah. So my question to you now, and help each other get into little peer instruction groups, and I can come around and answer any questions if you have them. Create that program. Create this absolute value program to run this. Take this idea. Let me give you a screenshot. There we go. Take this idea, implement it using, you got an ask block, of course. You got to use the answer variable. Compare it with a comparison block down here in operators, pointy ones. Bring out an if then else. I think you get the idea. And print the absolute value of that number that you were given. All right? Does the question make sense? Yeah. Those are also in operators. Do you mean these things? Less than, greater than, equal to? Yep, that could go right here. And this is false right now, so it's always going to run the else thing. But your code is going to check answer against something, and it will sometimes run the true stuff, sometimes run the false stuff. Okay? Yeah, so give it a try, and I'll definitely come around and help if you're having trouble. But see if you can get that working. Get this code running. And if you can do it quickly, definitely help your neighbors. And also, see if you can try putting the answer in a brand new variable. Don't use the answer variable. Like, get it from the user. Of course, it's got to be an answer then. Try putting it into a variable like called x or something, and then using x instead. Maybe you can even change x. You can set x to the different thing. You can't really set answer like you can in a normal variable. So that's an extra challenge on top of that if there's time. So yeah, give that a try. And here's what I mean by like resetting x. You got to put it, answer, maybe it's negative 42. Put it in a new variable called x, shove it there, negative 42, and then you're able to change x to positive 42. You cannot change answer. You just got to multiply it by negative 1 right before you show it. Hopefully that makes enough sense. So that is, yeah, those are your options. Please give that a try. Help your neighbors, and I'll give you plenty of time to do that. Well, this is up to you now. You could go back to the green flag if you really wanted to. All an event is a way to start your program. You can pick your event for this one. Plenty of time to try this. Yeah, is it all translating in your mind properly? Is it making sense? do if it's true, right?
True multiplied by.
If it's true, do this and this. If it's false, do just that.
I did that just on my time multiplying, but also
Multiply is just an operator. You have to say the result of multiplying over again with the initial absolute value. You got to put it somewhere that's circular. So maybe in that same block. Take another couple minutes, and then I'll bring us back. See if you can get it working with an extra variable if you've already done it. Mess with that variable. All right. Were there any questions that came up as we were trying this? All right, here's how I might do it. Let's give me a blank slate. So, all right, speed run. When the green flag gets clicked, why not? Some of these events are really fun. So, like, this is like when you yell at your microphone, it will run the program. So give that a try one day. When the green flag gets clicked, let's see. I would like to first ask, give me something. Give me an input. Enter a number. Enter a number and wait. That'll get placed into the answer variable, so I'm going to need that. And then the idea is, depending on what's in answer, like be it negative 42, positive 42, I want to do one thing or another. So if something's true about answer, right? If answer is negative, that's this part, is the input less than 0? So if answer is less than 0, and right now my answer is set to negative 42, so that's a true answer. Yes, it is less than 0 right now. And if it is, then we want to output not answer itself, in looks, I guess. We want to say answer times negative 1, I guess. You can have multiple uses of answer. The star block is times. Answer time, oh man, gets a little complicated. Answer times negative 1. So I'll take my negative 42 and create positive 42 and say that. Otherwise, if it's already positive or 0, I don't need to change anything. Say, just answer for 2 seconds. If it's already positive or 0, it's fine. It's already its own absolute value. Does that make sense? This is how I would do it. So enter number negative 42, prints out positive 42 for 2 seconds. Enter number positive 55, it's already positive, so we hit the else branch because this is a false statement. Is 55 less than 0? No, false. So it'll run the else. All right. Any questions about this? Is that what we got? Something similar at least? That's one way to do it. If you wanted to go through your own variable, let me save this before I mess with it. All right, harder mode. If I want to go through my own variable, I'll take this default one, rename it to X or something. If you wanted to do it this way and work with it, here's what you could do. You need to get answer into X, first of all. So like take it, put it in there, set X to answer. And so now when the green flag gets clicked, only these two things are going to run right now. Negative 42. I've just shoved negative 42 into X with these two blocks. Take whatever's an answer, put it in X. Then I can mess with X instead. Compare X to things. Compare X to 0. If it's negative, then I can change it. If X is negative, I could set X to itself times negative 1. I'm allowed to reset a value, reset a variable, that's as long as it's not answer. Answer I'm not allowed to reset. But X I totally can. And then this one, I don't need to do anything to X. I'll just leave it blank for now. But here's the idea. It's either negative and I need to reset it to make it positive. So if it's negative 42, like this is true, it will hit this block, this true branch, run this code. It will set X to itself times negative 1. And so now suddenly X is positive. If it was already positive, there's nothing I need to do. And then I can say X at the end for 2 seconds, because now X, whatever it is, it's got the right answer in it. I've either messed with it or I haven't, and now it's definitely positive. So I can have a blank else. If there's nothing you need to do in the else case, there's a block for that. There's just an if-then. See that? It's if this is true, then do the body, or it's called the body. I'll teach you that term later. If it's true, then do the true branch. Otherwise, just do nothing at all. So that's how that might work. If you only want to do one thing if it's true only, and nothing if it's false, you can just use a normal if block, if then block. So here's what's going on. Ask the user for a number, negative 42, let's say, and then we're going to put that answer into X, and now we'll work with X. If X is negative, so negative 42 is totally less than 0, we'll change X, we'll set it to itself times negative 1, so that's positive 42, and then we'll say X for 2 seconds. If I type a positive number already, like 55, that's placed an answer, then I put it in X. Is 55 less than 0? No. And so it skips this whole if-then. It doesn't do anything. And so it just keeps on trucking. And that's what I want, actually. X is already positive. Print that out. It's already its own absolute value. Interesting. So this is for when you don't need an else block. A false branch, let's say. Huh. So that's slightly more complicated, but maybe shorter. I don't know, depending on how you think about it. Are there any questions about that? So those are two ways to do it. Okay, I'll come and help you after I release the next assignment, and then give everybody time to work. How about that? All right. So I have promised to save all these things. I give them to you in the code from class. I hope you've been able to find them. If you want to look at these things, like here's what I did last time. It's here, this code from class link. You can click that. It's also in other places. Oh, sorry, I can definitely stop that now. So you're going to get all this code, and do study it, because it's going to help you for your next assignment. So let me go and release that, since you got one due, tomorrow. Let me give you your next one. This will be programming assignment 1, because you just did 0, right? So this will be due the 24th. So you got one due tomorrow. It's going to be the Thursday, right? So not this Thursday, but next Thursday. Same pattern. All right. Programming assignment 1. And here's what I want you to do. I'm forcing you to use a branch. It's a silly idea, but it will make sense once I explain it. All right. So for this assignment, you're going to have the Scratch Cat teleport, or another sprite. You don't have to use the Scratch Cat if you don't like the Scratch Cat. But whenever that sprite of your choosing has been clicked, that's going to be the event that kicks this off, your program should do this. I want you to make the sprite magically appear in a random place on the screen right after you click it. That starts this program. And then have the sprite inspect its location. So imagine that you just teleported your sprite somewhere on your screen. It has coordinates, right? The Scratch Cat knows where it is. It's got X and Y, and those are actually variables you can look at. They're somewhere. Maybe it's in looks. I can't remember where they are, but we're going to find them. There it is. In motion. There's your X position and your Y position. So like here's the Y position variable. If I move the Scratch Cat around, now as Y is 82. It's always set to wherever the Scratch Cat is. Now it's 5. Now it's negative 111. But there's a coordinate system going on. You can get those places where he is. And if your Scratch Cat or sprite of your choosing teleports to be above the half mark, the Y = 0 line, I guess, then just have him say that. Just have him shout out to the world, I'm in the upper half of the screen or something. I'm in the upper half. I'm above this Y = 0 line. If your sprite magically teleports, it's going to be random, right? If he magically teleports somewhere down here below the Y = 0 line, his Y position variable is going to be negative, and you have him shout, I'm in the lower half of the screen. Something like that. Something to that effect. Two different things, though. That's going to be your game. All right, so when you click the sprite, have him magically teleport to somewhere random, and then say something like, I'm above the Y = 0 line, I'm above the middle, if they teleported above the Y = 0 line, or have them say, I'm below that line, I'm below the middle, I'm in the lower half of the screen, if they teleport to down there. Choose whatever you want to say, as long as it's different, and feel free to make it fun. There are different, there's some pre-programmed sound effects that exist, so you can have them like pop whenever he teleports. But here's how I want you to make it work. I recorded a little video just in case it's a little too confusing. I'll mute myself, but here's the idea. I won't show you the code, of course, but here. You click on him, and he goes either above or below the line. You click on him, he teleports randomly, magically. I'm above, I'm below. I'm above, I'm below. Okay? Magically moving every time you start the program. Yours is going to start when you click the sprite. Okay? Not when you click the green flag. I didn't want to show you everything, but that's the idea. Every time you click him, it's going to do all this. Does that make sense? So yeah, just watch the video. I think it'll help too. So you are required to use these blocks. You must use a block that contains the word random somewhere, because he's got to teleport to, and every place on the screen must be fair game. And then you have to use an if-else block, because He's either above or below, and you got to do one thing or another thing. Okay? So those are your minimum requirements. Make sure to get those in. Feel free to make it as fancy as you want, though, in addition to that. So that's your programming assignment. If you have never programmed before, if you're in that group, that's what you're doing. And for this one, it's easiest for me to grade you in your programming assignments from now on if you upload a video. So please figure out how to record yourself and your screen. I can teach you how if you want to come to office hours. There's an easy way to do it in Zoom. I assume we got pretty good at this during the pandemic, so this is why I require it. It's very useful for me to grade. So please upload a video of your program running with your code available for me to see. You don't have to make it long. I just want to see every piece of it. Like click it a couple times so I see every way that it works. You can record it with your phone, with Zoom screen recording. There's a way to do it, and I will help you if you're struggling. But I'm going to start requiring you to upload videos of your programming assignment submission. That's very easy for me to understand that you understand what you're doing and for me to see all your code and see it working. Okay? If for this one, like you're not ready, you don't have a laptop that you checked out from the library yet, you're trying to get that. If you're unable to upload a video for this one, then it's okay. Just upload a screenshot or a couple screenshots showing everything working. And please come to me if you're struggling on figuring out how to record videos because next time I'm absolutely requiring video recordings. Okay? Try to get it working for this lab, for this programming assignment though. Okay? So that's how I want your submission, and so you're going to upload some file in whatever format your program lets you. So that's for if you've never programmed before. If you have programmed before, you can do this next stuff. Read these chapters of that book and do exercise 5. Also record a video where you show it working now. All right? That's how I want to do it for you if you've programmed before. And also keep in mind that you can come to me and we can give you something custom that's more suited to your interests if you're in this group as well. So those are your 2 options, and this will be due next Thursday. Any questions about your programming assignment? So, video recording, the way of the future. All right. So that's all I want to record.